Hello, and welcome to the Scanning Electron Microscopy Validation Analysis presentation. Let's start. So, an overview of what we're going to talk today. We're going to overview of how SEM EDX instrument works, the description of how SEM EDX instrument can be used for both microscopic and elemental analysis, sample types that can be analyzed using SEM EDX, different sampling methods that can be used using this instrument. We're going to go over an overview of a journal article that uses this instrument, SEM EDX. We're going to talk about what microscopic or elemental analysis is used in this article, what samples were analyzed in this article, what sampling methods were used by the author, and the evaluation of the results and conclusions of the article, what the authors did well in this presentation, and what ways could evaluation of evidence or validation be improved, and an overview. So, the overview of how SEM EDX instruments works. These are commonly used for analysis of elements in a sample in any forensics field. So let's talk about the SEM part. SEM is an electron microscope that uses an electron beam that is applied to a sample. This generates and detects secondary X-rays, as well as detects backscatter, which then generates an image. So the EDX side. EDX is an addition to SEM. So the EDX detector is placed near the SEM detector. This detects the photons coming from the secondary X-rays, and it collects X-rays in the signal channel, which maps the elements by sending X-rays to the detector, which concludes a spectrogram of the elements. So the description of how SEM EDX be used both a microscopic and elemental analysis. So SEM is an electron microscope. It uses lens and eyepieces. Material being analyzed can be seen by the naked eye. It enables examination of small sample particles in high resolution and creates analysis of structural surface. So the EDX side is the addition to SEM. This detects X-rays by making electrons jump. It creates photons to help analyze the elements, and detects the ionization of those elements. So what sample types can be analyzed using SEM EDX? The sample types that can be analyzed includes biological, explosives, glass, gunshot residue, paint, soil, and even toxins. So the different sampling methods that can be used using SEM EDX. The type of methods include carbon thin layer coating, ZAF correction with SEM, which uses fingerprinting on certain key feature characteristics of elements. Support provides stability and secures sample from the environment. The liquid sample coated with dry stub. And the solid sample, small amount loaded on adhesive tape and sample sprinkled. So now that we know what an SEM EDX is, let's go over a review of a journal article. So the soil examination of forensic trace evidence lab was what was in this article. It provides 29 samples of soils were examined from 9 different locations in Australia as 17 were archived. They compared 3 different methods, the SEM EDX, the X-ray fluorescent spectroscopy, and the LIBS. Today we are only going to talk about the SEM EDX. So the purpose of this analysis was to possibly apply typical elemental profiling used to analyze a trace evidence for screening a soil prior to shipping to the lab. So what microscopic elemental analysis was used? the Joule 6480LA SEM instrument with a SEM control user interface software. This was at low vacuum, pressure of 30 pascals, EDS current 1 nanoamp, working distance 10, magnification of 200 times, with an acquisition time of 200 seconds, and the analysis station JED series used for SEM EDX data collection. So the samples analyzed in this article. 29 soil samples from different areas in Australia were analyzed. This includes surface soil and subsurface soil. It analyzed elemental compositions of the soil and compared to 17 soil samples that were already archived in Australia's archival. So the sampling method used in this article were oven dried. The soil samples were oven dried for 24 to 48 hours at 47 degrees Celsius, lightly crushed, with a mortar and pestle used to break up the agglomerate, and dry sieved. So sampling methods continued. So approximately 10 milligrams of soil sample compressed at approximately 2 tons using 13 millimeter die set created thin and durable soil discs. These discs were mounted onto the carbon tape on SEM stubs, and the SEM control user interface software was employed. So the evaluation of results and conclusions. So SEM EDX data showed that magnesium, aluminum, and iron were in these soil samples, with the concentrations to be highly discriminating with 82%, 72%, and 73% discrimination. There are a high level of discrimination with the soil sample set analyzed, 99.5% discrimination of SEM EDX for both Canberra area and Australian-wide soil samples. So the conclusion was that this analysis was effective in differentiating Australian soils without needing destructive sample preparation. So the evaluation of results conclusions continued. So this provided also information of the soil compositions, bulky compositions, and also concluded that should not be used for determining soil mineralogy. So what did the authors do well in this article? They used different types of methods instead of just SEM EDX analysis. They concluded that both SEM EDX and XRF were better and useful out of the group for elemental analysis. They provided great resources that added to SEM EDX being great discriminatory analysis. And they used not only analysis of soil samples from 9 different locations in Australia, but also analyzed control samples that were already archived. So what ways could evidence evaluation or validation been improved? Choosing more diverse soil samples could even give better ending results. Maybe even finding more results from different countries, making finer soil samples, and choosing very diverse areas of vegetation or anything that could be added as composition of the sample, like in towns near factories. So anything that could give more discriminatory analysis that it came from that part of Australia. So a review. We got over the overview of how SEM EDX instrument works, the description of how SEM EDX can be used for both microscopic and elemental analysis, sample types that can be analyzed using SEM EDX, different sampling methods that can be used using SEM EDX, overview of a journal article that uses SEM EDX instrument, what microscopic or elemental analysis was used in the article, what samples were analyzed in the article, what sampling methods were used by the author in the article, the evaluation of the results and conclusions of the article, what the authors did well in the analysis, and what ways could evaluation, evidence, or validation be improved. And that concludes our topic today.